Okay, in this presentation we are going to look at sample spaces. So essentially what we're doing is we are sampling from two urns. Suppose one urn contains 3 balls, one red, one blue and one green, and a second urn contains 3 balls numbered 1, 2 and 3. An experiment consists of 2 balls being drawn at random, i.e. one from each urn. So it's a straightforward enough exercise really. Just the question is, write out the sample space for this experiment. So this is just a quick question just to get you used to all this stuff. So the first urn, just recall that we have one red, one green and one blue. Okay, or one red, one blue, one green if you prefer. So one of 3 colours, and we have a second urn, 1, 2 and 3. So the experiment consists of 2 balls being drawn at random, one from each urn. So that's just a sort of recap of what we're told, which is a short question, as still have to do it. So anyway, R represents the red ball from the first urn. So these are all the possible outcomes, or represent all the possible outcomes. B represents the blue ball from the first urn. And G represents the green ball from the first urn. And 1, 2 and 3 is straightforward enough, the numbered balls from the second urn. Okay, so the sample space consists of all possible combinations of drawing 1 ball from each urn. Okay, so in the first case, what we could do is we might select the red ball from the first urn and then one of the 3 balls from the second urn. So we could end up with R1, R2 and R3. Likewise, we could select the blue ball at the first urn, and we could end up with one of 3 numbers from the second urn, and that gives us B1, B2, B3. And finally, we could select the green ball from the first urn, and again, pick one of the 3 numbers. So we could end up with G1, G2, or G3. So the sample space is essentially that entire list written out, okay? Now, in this case, it's straightforward enough to actually sort of write out a full list because it is fairly tractable in this instance. 3 balls from 3 in the first urn, 3 balls in the second urn. That's 9 possible outcomes. Okay. In other cases, it won't be so easy to spell it out, but even still, a sample space will exist in theory. So yeah, that's it. We'll leave it there.